Alrighty, so figured that wouldn't hurt to go through, do a quick recording of going over the first one of the practice quizzes. So this is practice quiz 3A. And for this one, we have a starter file. We've got our little canvas diagram and our upload. So as with quiz 1, you are going to be getting a paper copy of the quiz that you can go through and do. But you will need to get logged into Canvas, well, partially to be able to submit your file and partially to download the starter file. So for the actual quiz, there's going to be an announcement posted in the morning with the starter files for that quiz. However, for this one, it is just attached directly with the practice thing. So we'll get that downloaded, crack it open, and let's see what we've got to do here. So initially we've got our starting file, so it's just a sort of standard revolve. This is currently shown as hidden lines visible, so if we want we can set this to shaded with edges, which is the style that we're used to seeing it. It also has the tangent edges fonted, so we don't get that as a solid edge, but we do get something indicating that there's a boundary there as it goes from curved surface to flat surface. And let's take a look at what we've got. So we're given this list of changes that we need to make for it. We want to add the indicated equations. There's an equation over here stating that the base dimension, this 3 here, is equal to the width plus 2 divided by 4. We've got a hole pattern, so on the back side of our object over here, we've got a hole wizard callout, and then zoomed in detail B, we see a closer look at sort of the spacing and all of that for it. Is this... No, yeah, that is a back view. We've got our section view taking up the front view, and then we've got our right view over here. A couple of detail views zooming in to let us see things a little better. Alright, anyway. So we've got that whole pattern that's sort of shown over here. I guess this one's kind of indicating it on the other side, but we see it's got a 2-unit diameter bolt circle, and we've got 7 of them with one of the holes all the way at the tippy top. So then we also have a rib, so that's this sort of 2 wings and cylinder shape going on in the middle here. A shell hollowing the whole thing out. A fillet, so that one appears... Where is the fillet? I think the fillet's applied to the handle. Yeah, it's a little hard to see on the... There we go. Where is the fillet, actually? Oh, the fillet's on the back. Okay, there we go. So we got our radius of 2 fillet on this back edge here. We see that we do have the rounded bit on the outside and the sharp corner on the inside, so that tells us that this fillet needs to happen after the shell. We've got our handle component, so that's this chunk down here. That one is solid, so that tells us it needs to happen after the shell. And a second configuration where we're going to have the holes suppressed, and we are changing the width dimension, so this width here, from 10 down to 8. Alright. So, starting off, it's a good idea to figure out what needs to happen before the shell and what needs to happen after. So the equation, that can happen either, actually, that's one that I always see missed while grading these, so that probably wouldn't be a bad idea to just add now. To get our equation, it is first useful to see our annotations. We can right-click the annotation folder, select Show Feature Dimensions, and that will show us all of the dimensions that were used to create our model. We have our 3 dimension, this one's our base, and we have our 10 dimension, this one's our width, and this one is defined so that the base is equal to the width plus 2 divided by 4. So we can go through the equations menu, or if you double-click on the number, that brings up the modify box. And then from there, we can do equals to turn this into an equation. We've got our parentheses, we've got our width, plus 2. This 2 here is being used as an additive or subtractive modifier on the equation. So we need to make sure that its units match the units of the thing that it's being added to. This model is in inches according to the drawing, and in inches according to our starting file, so it's going to be plus 2 inches, and then divide by 4. Checkmark. Cool. So we get that little red sigma symbol next to the 3, and that tells us that it is driven by an equation. 1 down. Check. The holes, we do see that the holes are cut into the back of our object, and also we see that these holes have a sort of shell around them. So thinking to our shell feature, it automatically applies to the entire model. So if the hole has this sort of wall all the way around the cut, that tells us then that this hole needs to be added before the shell feature. If it was added after the shell feature, it would just pass through the shell. It would just pass through the wall of the object, but it would not have this internal geometry. So the hole wizard needs to happen before the shell, the pattern needs to happen before the shell. The rib we do see is solid, whereas the rest of the object is mostly hollow. Here, wait. The rib happens inside of the object. I guess we're slipping a little bit. The handle I'm also going to create using a rib feature. But the rib on the inside, that one is dependent on the inside of the object, so that needs to happen after the shell. The shell is the shell, and it happens when the shell happens. The fillet needs to happen after so that it doesn't propagate to the inside. The handle needs to happen after because it's solid. And the second configuration, it's usually best practice to do configurations at the end, so we'll leave that for after as well. Alright, so that pretty much tells us we need the hole and the pattern to occur before the shell. And for both of these, they happen on this back surface, according to what we see in the back view over here. And we see that we've got one hole that's sort of directly up from the center of our object, and it is on a diameter of 2 bolt circle based on what we see in detail B. So for that, we're going to select the surface, and then we go over to our Features tab and go Hole Wizard. This automatically generates the hole information for us, and importantly, because we selected the surface first, when we do our positions, it's going to be nice and easy to define. So, how do we go about making our hole wizard? We've got the hole callout over here. So that tells us that we've got 7 of them with a through hole diameter of 0.1 and a depth of 0.5. And then we have the counter bore. No, I think that's countersink. No, it is counter bore. Okay. It's the counter bore symbol, so it's the upside down staple shape. That one matches the head of what we see for the counter bore here, or counter bore here. Let's reset. So that looks correct, and then the counter bore has a diameter of 0.2 and a depth of 0.2. So going down our list here, we've got the hole type, as per what we had talked about in the lab. The only thing we really need to change with these drop downs is making sure that our units match. So we're in inches, so we need to make sure we have this set to ANSI inch. And the type, the size, and the fit, those don't matter because we're going to be overwriting them with our custom sizing. So the through hole information comes from the top row of the hole wizard. So that's going to be 0.1 units. The depth of the hole is this 0.5, so that's going to be our end condition. It's going to be blind 0.5. The counter bore, we see this has a diameter of 0.2, so that's for our counter bore diameter here, 0.2, and then the depth of this is also 0.2, so we'll plug in 0.2 there as well. So this should have our hole set up the way that we want it. Then we can just go to our Positions tab, and that will open a sketch on the surface that we had selected. We can use the Point tool to place down an instance for our hole, and just to make sure, or just to make the bolt circle a bit easier to visualize, I'm just going to use the Circle tool to just draw that in. And then importantly, this is not being used for geometry, so we'll check the For Construction box. Then we can place one of our holes. We do see there is one directly up from our sort of central axis. So that seems fine. And then we can dimension our circle. So this one's bolt circle, diameter of 2. Cool. Sketch is fully defined. We're all good there. Gonna hit our pop back over to our type actually real quick. Yep, everything looks good. Check mark. One thing to note, the hole wizard by default is going to have this sort of conic end cap on it. So if we don't want it to have that sort of point to the end, which based on the section view over here, it looks pretty flat, we do need to enter back into the hole wizard, so edit feature once again, and then that's going to give us a new box with the end surface angle. So this one should be 180. That makes it sort of flat on that bottom face. Check mark. Cool. Other thing I think I'll bring up while we're over here, when looking at the Hole Wizard, the measuring usually is going to be measured to shoulder, so we leave that as is by default unless something tells us that we're going to the tip of the hole instead. When the end is 180 degrees, it doesn't matter, they're the same distance, but in general, you leave it as the default unless specified otherwise. Cool. So there's our Hole Wizard. Then for the pattern, we do want to do this as a separate feature instead of using the Hole Wizard itself and then doing an entity pattern or a sketch pattern. Doing it as a feature pattern tends to lead to better results as far as the computation goes. So with this one, it is going to be circularly patterned around this cylinder. We want the Hole Wizard as the thing that we're patterning, and then this is going to be equal spaced. We don't have anything telling us angles, so it's probably even, and there are 7 of them. Full preview, looks right, check mark. Cool. I'm also going to hide our feature dimensions here just so they're not cluttering us up. But that looks about right. Then we can shell our object. So for that, we'll activate our shell feature, set this to show preview so we can see what we're doing. And for our shell thickness, we do have a wall thickness note specifying that it is 0.1 units. So for that, we're going to select this front face, have 0.1 units in there. We're selecting the front face to remove that from the object. If we don't have this selected, it will hollow everything out, but we're going to be left with this cap on the end of the air horn, so that wouldn't really work all that great. But check mark, take a look. It does seem so far like it matches up with what we're going for, so not too bad overall. Alrighty, let's do that fillet next. That's another one of those quick and easy features that is very easy to miss on accident. So this one, it's got a radius of 0.2, so we'll plug in 0.2 there for our fillet parameter. Select our edge, check mark, and let's do the rib, I think. Yeah. So we do see on our section view over here, where it cuts through the middle of it, it shows us that this sort of central outcropping starts 2 units in from the right side of our horn. So we effectively are going to need to create an offset reference plane using this thin surface. So we'll select that surface, plane. It's going to be 2 units in, and we'll flip that so that it's measuring it in the correct direction. Check mark. Then we can create a new sketch on this reference plane. And we see that for our rib, we've got this circle in the middle, and then it's got these wings sort of going out to the sides. So we'll do the circle centered in the same central location there. We've only got the 1 center mark, and we've got a couple of circles, so that tells us that all 3 of these are going to need to be concentric with each other. And then we've got the wings for our rib, just seem like they go straight out from the sides. So we've got one, and we've got the other. You can double click with the line tool to auto stop it wherever you were. And then for this one, we've got a diameter of 1 unit. So click place 1 unit. As with the rib feature, as part of the rib feature, we don't need to fully define the sketch. It's okay if the end points of our lines are blue, but the lines themselves need to be black. So we've got these 2 endpoints that are underdefined, but when we apply the rib feature, SOLIDWORKS is just going to extend them until they hit something and then add the material from there. So it functions as a thin extrude, effectively. So our sketch is done. We pop over to rib. We see this one has a rib thickness of 0.1, so we've got 0.1 plugged in there. We make sure that we've got the little gray arrow is pointing into the horn, so our direction should be good. And check mark. Cool. Well, that looks about right. Nice stabilizing bit of material there to keep it from collapsing in on itself. And the last bit that we've got before we have our configuration is the handle. So for this one, We do see its geometry pretty good in the front view, so that tells us that we're probably going to want something on or parallel to the front plane. And based on our back view and right view, it looks pretty centered. So effectively, we're going to want to create a new sketch on that front plane, and then we can draw in the outline of it. This is going to be interfacing cleanly with this cylindrical shape at the end of the horn. So effectively, I think that the rib feature is going to be a good pick, because that allows us to get these nice clean interfaces. And for that, what we can do is just draw in sort of the externals of it, but we leave the loop open where it would interface with the object, so that way the rib takes care of the interface for us. From there, we can add in our dimensions. We see this one is 4.5 units down from the central axis. So we can use our origin, measuring to there, 4.5. We've got the right hand of the right hand side of the handle is 2 units over from the back edge. So back to our origin. There we go. Back to origin, to that point, it's 2 units. Got 0.8 units for the width here. And then the left side of the handle is a 100-degree angle. So from there to there is 100 degrees. You can measure angles between any 2 non-parallel straight line segments. Awesome. So we've got that down. Pop back over to features, go to our rib. We want the arrow pointing in to where the material is, so we'll check that box. And this one has a thickness of 0.8. And it looks like it's pretty centralized on our object, so we're going to be using the both sides option there. Check mark. And that we see gives us this nice connected bit to our object. So, going down our list, we added the equation, we did the whole pattern, we did the rib, we did the shell, we did the fillet, we did the handle. The last bit is the second configuration. So whenever we're working with configurations, we go over to the Configuration Manager, right-click the part name, and add configuration. So for this, we're not given a specific name for it, so I'm just going to call it config2. Reasonable enough. And double check, we do have our 2 configs. So the second configuration is going to have the holes suppressed. So we're going to pop over to our design tree. The holes are defined by this counter bore and the circular pattern. As the circular pattern is a child feature of the counter bore, suppressing the counter bore itself will also suppress the circular pattern. So you can right-click the C-bore, go to Configure Feature, and then we can check that we want it to be suppressed in Config 2. Okay, cool. So, in Config 2, we've got that suppressed. And then the other bit that I was not thinking very far ahead about, apparently, is that we also need to change the width dimension. So if you right-click on Annotations, Show Feature Dimensions to get that back, this 10 here is our width dimension. So if you want that to be different in this configuration, you right-click on it and go to Configure Dimension, and in Config 2, we want it to be 8 units. Hit OK. See that it's a little bit stubbier. The equation did follow to match up. And then we just double-check to make sure our default configuration is still good. Cool. So, looks like everything followed along the way that we want. So we'll just save our file and call it there. So make sure you get it named correctly. I would recommend with the practice quizzes you do go through the upload process just to make sure that you're comfortable with it. And yeah, figure we'll call that there. If you've got any questions, feel free to reach out. Otherwise, wishing you all the best of luck.